Welcome back, fellow programmers, to the Intermediate Programming Tutorial Series, Lesson 15. I'm Chili, and we are working on making a little platformer engine here. So let's continue with that. But first, I want you to check out the Solution Explorer and click left here. Click on this left tab here at the bottom, and you'll go to Class View. And here you can, if you haven't already done this, pardon me, you can check out all the classes that we've created here. Look at them all. Look at all those classes. Chilling out. Like they think they're better than us. But yeah, this is going to be useful in the future, so I'm probably going to be using this a lot. Probably more than the Solution Explorer. And maybe we'll learn a few tricks about using this thing later on. But for now, let's what's the word I'm looking for? Let's review how far we've made it. So we can run with our character now. With our little dude. Look at him run. And yeah, but we can't run to the left, and that might be a minor problem in the engine. You know, just a slight deficiency. We could leave it like that, but I think we're going to add moving to the left. Just for completion's sake, because you know I'm a completionist. The question is, how are we going to go about this? Now, take a look at our... we got our player running and our player standing here. These two state classes. I'm just thinking, my brain is stalling here for a second. I'm wondering if this is the H file, right? Yeah, it's the H file. So if we double click on the class name, it takes us to the class definition, right? And if we double click on, like for example, this method name, it'll take us to the implementation of that method. So we don't have to fuck around, you know, finding the CPP files, finding the H files. It's all here. It's all here for us. We're all part of the dope show. Now, here's the thing. It's time for some real talk. Real talk. We got ourselves a running state, and we got ourselves a standing state. Ugh, horrible handwriting. And we've got some state transitions between them. Specifically, we press the right button, and we this is press right button. This is release right button. So these are our state transition triggers, the events which trigger the transition between these states. Basically, we press the right button, we start running, we release it, we stop running. Very simple. Now, if we wanted to move to the left and the right, we've got a couple of choices about how we're going to go about this. Well, probably lots more choices than a couple, but a couple that spring readily to mind would be, we could make new states. We could call this one, we change run into run right, and stand into stand right. And here we go run left, and stand left. Okay? And then we can, you know, make state transitions here. This would be press right button, press left button. So if we're running right and we press the left button, off. I fucked it up. Let's just fix this here. I've said it before and I'll say it again. Talking and basically doing anything is almost impossible for me. Okay, so we press, let's say we're running right, we press the left button, we start to run left. Makes sense. Here we go. This is press left button, release left button, right? And if we're standing facing the right, stop that. And we press the we press the left button, then we're going to run to the left, and same thing here. So here's what we get if we try to make a separate state for facing right and facing left. And if you think about it for a second, you're going to realize that the code inside of, for example, run right and run left is going to be almost identical with a few changes. So you're going to get a lot of redundancy and stuff you're going to have to copy and paste and bullshit. I mean, you can do something like you got your state class, and you derive from that your run, and you derive from that run right and run left. And you could keep most of the common stuff in here with some shenanigans, but it's not going to be super pretty, and it's going to make your class hierarchy more complicated. And you're going to have to do this for every single state. So every state that you create, standing, you have to go stand and then stand right, stand left. And it's just going to be a pain in the ass. Whereas, the other way we could do it, which is the way we're going to do it, is we just have running and standing. And we got transitions here, which is going to be press direction button and release direction button. And inside of these states, right, in fact, inside of every single state, I think I'm going to probably put it in the core. So we have the pointer to the core. And inside of here, among the other core variables like the position and the velocity, we're going to have the direction facing. So we're going to add a new variable to our core of our sprite to remember what direction we're facing. And that way we're not going to have to duplicate states for the right facing and left facing states of like everything you're doing with a sprite, running, jumping, falling, everything. Because that would be a pain in the arsehole. So the next question is, how do we represent direction? We could do it like with a bool. We could say bool is left. And if it's not left, then it would be false. And if it is left, it would be true. That would be simple. A little tidier way of doing it would be to create a enumeration with the values of left and right, and possibly an invalid value, an uninitialized value. But what we're going to do is we're going to create a whole new fucking class for the value, for the data type of direction. Because that is how we roll. We don't have enough classes in this list. We need more. So let's make classes. First of all, we're going to add a new file. So let's add a new item. And we're going to make a header file. I don't think I'm going to make a CPP file for this one just because it's a very lightweight data type. I'm going to call it by direction, because it's only going to store like two choices, right, left or right. So it's not a full-fledged direction class, in my opinion. It's just a bi-direction class. Pragma once, as usual. Now, let's make our class. Class by direction. Yeah. Okay, so now what we're going to have is inside of the class, we're going to go private. I don't think we'll be deriving from this one, so well, we don't worry about making it protected. Doesn't matter either way. And we're going to make an enumeration. What should I call my private direction enumeration? I'm going to call it Biter. Now this, the way I'm thinking about things right now is this is not going to be accessed by the external world, so it's not super important what we call it. It's only going to be effective inside this class. And the values are going to be, we'll start off with left and right. If need be, we'll add a third one, which is like just, I don't know, invalid or uninitialized or something. So enum bidirection with the values left and right. And we're going to create the an actual member off of this enumeration called dir. Dir. I love that sound. Dir. Public. All right. So now we need some stuff. We need some tech here for our bidirection. What am I thinking here? So we're going to need to be able to compare bidirection values to each other to determine, you know, if something's left or right. So we'll start off with comparing. Now we want to be able to create a bidirection. Constant bidirection. Dir. I don't like that. D. That's good. C. Copy. D. We'll call this D. This is like a there's a specific name for this kind of constructor. It's called a copy constructor. And it's used in certain situations, but I forget them. And it's not important. But if you make a constant reference to the data type that you're trying to construct, and that's the only parameter, that's called a copy constructor. I think. I'm pretty sure that's how that works. Anyways, we're going to just go dir is equal to d dot dir. So we copy the value of the enumeration, and we put that into our current object that we're trying to create. We just copy this one. We copy the value stored inside this bidirection class. And that's how we'll create new bidirections. What else? Yeah, I want to make a another value here. Invalid. And I want to make a bidirection, a default constructor. Dir is equal to invalid. So if you create it without bidirection, there we go. So if you create a bidirection value and you don't, or a bidirection object and you don't specify a direction to copy from, it defaults to invalid. All right. Now you might see some problems in this, and you would be right to see them, but we'll handle them later. For now, I can't remember if I showed you guys how to overload operators, but you can overload operators, and it's kind of cool. You shouldn't overuse that ability, but it comes in handy. So when we're working with directions, like for example, if we want to know whether a direction is moving to the left or right, we would take a right direction and we would ask, is this direction equal to right? And if it is, then yeah, it means we're moving to the right. Or we could just create Yeah, I think we'll do that. So we'll go bool. Bool is left. Const. Return dir equal to left. And bool is right. Const. Return dir equal to right. Bool is valid. Const. Return dir not equal to invalid. Just for completionism's sake. So here's how we'll check to see, check what kind of direction we have. Now, if we have two direction variables, we want to see if they're the same or if they're different. We have to compare them. In which case, we're going to use this. Bool operator. No, where's my equal sign? There it is. Double equals constant by direction RHS, which means right hand side. There. So why do I put this as RHS? What's happening here? I am overloading the equals operator. So now, if you do something like, let me just type in some example code. I'll put it down here so it makes less dumbness. And so we have, let's say we have a bidirection A, bidirection B, and we can go A equals B. We can go like if A equals B, and that will call this operator, and A will become the object for which the operation is called on. So it'll be like the this pointer, right? This will point to A, and RHS will refer to B, and that's how it's going to work. So this parameter here is what's happening on what comes on the right hand side of the operator, and the left hand side is the actual parameter for which the member function call will be made. And so this will point to A, RHS will be B, like I said before. That's how operators work. So, how do we work this? Well, we'll just do dir, or we're going to return dir equal to RHS dot dir. Bool operator not equals. Copy this shit. Probably took longer to copy because I had to look at my freaking keyboard. I'm gonna say it's this one. I'm gonna say it's this one. Yes. There we go. Return. Yeah, I'll just do the same thing. No, wait. Dir not equal to RHS dot dir. All right, what else do we got? Bidirection. Let's overload the assignment operator. So the assignment operator returns by direction operator equal sign const by direction and RHS. So we do, what do we do? dir is equal to rhs.dir, right? We assign that. And then we return this, right? Because we're returning, I think the assignment operator has to, I don't know if it has to, but it generally does return a reference to the object that has been assigned to. So you can like chain on additional operations if you wanted. So you just return, you dereference to this pointer and you return that. But yeah, that's all that is. The assignment operator. What else do we got? What other operations do we want to define here while we're at it? We're going to go by direction. Get opposite. Const. Wait. Bam. This one should be const because we're not changing anything, we're just comparing. This one should be const. I just like my const correctness. It makes me feel good. It's like when you get your dietary fiber. There we go. Oh, failed it on the last moment. Okay, so get opposite. I'm going to create a new function here. Bool. Set left. dir is equal to left. Why did I put that bool? That's a void. That is clearly a void right there. Void set right. Okay, so we got this. Get opposite. So we want to return a bidirection. Bidirection O. O. If dir is equal to left. There we go. O dot set right. Else if dir is equal to right. O dot set left. There. So we create a I gotta return that. Return O. Create a new direction. Set it to right if this direction is left, set the opposite direction to right. And if this one is right, set it to left. Otherwise, it's going to stay the same, which is invalid. So if this one is invalid, the opposite will also be invalid. And then return the opposite. So this will poop out a direction which is opposite to the current one. And by direction reverse. Not constant. And we'll just do kind of the same thing here. Why don't you like this? dir is undefined. Oh, okay, never mind. Okay, we'll copy that, paste that there. If dir is equal to left, where's my delete key? Set right. Otherwise, set left. That seems nice. Is left, is right, is valid, set left, set right, reverse, get opposite. We got the assignment operator. We're gold. We are gold. Now, one more thing. I'm going to create a static function here. Static by direction right. And what this one will do is it'll create a new by direction d dot by direction d. Why is that only giving me right? Static by direction right. It's a static function, but it's creating an actual instance of bidirectional. Okay, I know why. It's because I just didn't have that. D. There we go. Set right. Return D. So this static function will just return a direction which is facing right. And static by direction left. By direction. I mistype it again, as is my birthright. Yeah, because I suck at typing. Set left. One day this keyboard is going to crap out, and then I'm going to get a new one. And then, my friends, things will change. Build. Wait, I don't want to build. I just want to make sure. So now I can create a new right or left bidirection and feed that into this constructor, which will let me construct a bidirection in a certain direction if I wanted to. You'll see what I mean when we get there. This is static functions, so they can be called without any particular object instance. They can just be called generally. Okay, so here are general, what do I call it? Utility functions. I might add a couple more, but this is a good start. I believe this is a nice start. So now we have our direction class, bidirection. Wasn't that fun, people? We created a bunch of functions. I didn't really explain to you why we need them, except that I'm pretty sure we will need them. Once you get better at like writing classes like these, like classes for kind of generic data types or simple data types, you're going to have a good knack of just knowing what kinds of operators and functions you're going to need in the future and just write them ahead of time. It'll be simple. Now, what's the next thing we need? Well, so the next thing, I'm just going to talk while I Control Z out of this bullshit, is we're going to need new sprite images, right? Because, obviously, if you're facing right or you're facing left, the image is going to be different than when you're facing right, unless your object is symmetrical in the right and left planes. In the horizontal. Horizontally symmetrical, that's what I'm trying to say. But our dude is not horizontally symmetrical, because that would be weird. So, we're going to need, like if we got our dude and he's facing this way, whoa, those are some legs, there's some feet on this dude. You know what they say about a guy with big feet? Big hands, big feet. They say, damn, you got big feet. And that's when we're facing this way. And when we're facing this way, gonna look like this, right? So, what do we do? Well, again, we got some options. We could create a whole new set of images for moving left and right. So different image files in a folder, and we could call them, like, for example, run left 00, run left 01, and run right 00, run right 01, and so on. But that would be horribly inefficient because, just think about it. The images are just mirror images, right? So you could just like flip this one over and get this one. Flip it and you get the mirror image. And flipping, like doing a flip like that, mirroring an image horizontally or vertically, is really freaking simple. So, like, think about it. Like, if you already don't know how to do it, just think about how you would go about mirroring an image. And I think, I don't know, it's not that hard. You can do it. You can do it. Cut his fucking head off. No. Where is our, I'm going to go here. Surface sequence. Let's go here. Shall we create a new class? I think we shall. I want to create a new class. Let me do it. Nope, that's not it. This one. Add. New item. H file. And we're going to call this a bi... Wait a minute. What was I doing? Bidirectional surface sequence. I could just call it a bi-surface sequence. That would be shorter. Some people may think it means bisexual, but that's okay too. I do not judge. Pragma. Once. So, class bi-surface sequence. What do we include? Well, let's include include surface sequence, because we're going to need that. Not bi-surface sequence. Dude, that's what we are. We can't include ourselves. That would be weird. And it would not work because the pragma. Surface sequence. Is that not a thing? Why do you not like me? Cannot open. Oh, I know why you don't like me. It's because I did it wrong. I did the bad thing. So, what did I do wrong? The thing I do wrong every night. Pinky. I fucked it up. Where is my... I'm going to say framework. Okay, so we got our bidirection and we got our surface sequence here. Thank you very much. Let us go. Let us pray, son. Where's my bidirection? You go bye-bye. Don't delete. Just remove it. Yeah, we're going to save it. That's fine. That is good. Save that. Also remove. And then once it's all closed and saved and all that good stuff, we go here. We go copy. Cut. We go cut. XCV. Then we go back here. Assets. Paste. Every day. Every single day I regret making this asset folder. All I wanted to do was I didn't want all my junk in here because it looked messy with all these other shit. Just wanted to put in a separate folder, but no. Gotta fuck with me every single time. Okay. Now, all I gotta do is go into assets. We go bidirection. Where's bidirection? bidirection and bisurface sequence. And I'm going to drag those over here. Perfect. Bloody perfect. And now this works. And all manner of things are good. All is well. Okay, where was I? Shit. I'm making a bisurface sequence. So I want, I'm going to say protected, because I might sometime in the future derive from bisurface sequence. I don't know. I'm going to hedge my bets. And I want a surface sequence left sequence and a surface sequence right seek. Left seek and my right seek. Your seek and my seek. Escargot, my cargo. Private. That's not what I want. Public. Public. So a bisurface sequence will contain two normal surface sequence within itself. And it's going to have to implement most of the same functions that surface sequence does. Where is it? I mean, I could make a inheritance, whatchamacallit, like I could make a surface sequence, and then I could inherit from that single surface sequence and bisurface sequence, and that would be good, but meh, whatever. I don't feel like it. Today, I don't feel like it. I don't feel it. I'm not feeling it. So we're just going to do, we're going to compose. We're going to use composition instead of inheritance here. Or aggregation, or whatever those fucking words are. Man, people like making up words for programming, and it's hard to remember them all. What was I doing? Started mumbling. I couldn't. Oh yeah, I was going to go to surface sequence and figure out what stuff I need to implement. Well, I need a draw function, obviously. And I'm going to need... yeah, advanced, that's going to be a thing. Most of these things are going to be a thing. Okay, so. What I want to do is I want to make a function. I want to be able to mirror a surface. So if I got a surface, I want to be able to get the mirrored image of that surface. You catch my drift? So how do I do that? Where do I do that? I feel like I could do that in the base class, because mirroring isn't going to be any different in this one and in this one, but then what should I do? What should I do? Dilemmas. I could make it a virtual. Yeah, I'll make it a virtual function. It's going to be fine. Virtual. Surface. Pointer. Clone mirrored. Const. How do you like them apples? So it's going to return a pointer to a new surface, and the whoever receives the new surface is going to have to worry about deleting it later. They hold full responsibility for it once it's been cloned. That is the That's the contract here. Now, if I do this, creating a new surface. D3D color pointer to surface. Yeah, what I'm going to do is I'm going to create a public. I'm going to create a protected function here. It's going to be not going to be virtual. D3D color pointer to. Get mirrored. What do I call that? Surface? The whole thing is a surface. Get mirrored pixels. Pixels. I'm thinking that's all I need, really. That's the best I can name it right now. Const. So this one's actually going to do the mirroring. And then this one is just going to call this one. Create a new surface using this. Yeah, it'll be fine. It will be fine. It's going to be fine. Yeah, it'll be fine. Okay, so how do we mirror the pixels? That's the question. We're going to use a what are we going to use? We're going to use a loop. We're going to use a nested loops here for kind of like this, only better. Where's my thing? Copy that. Paste that there. Okay, that's a good start. No, I didn't want that. I wanted this one. Draw. Oh, okay. I just fucked it up over here. Undo that. Whew. Copy that. There we go. Okay. So, we don't want this get height. We want height. And width. So we're going to loop through all of the pixels of the source surface, D3D color. Okay, we don't want bitmap here. So we want to create, first of all, we want to go D3D color pointer to. Mirrored surface is equal to new D3D color width times height. Okay, there we go. Now we loop through this. Let's go back to Photoshop here. So if we've got an image here, this is our source, it's our destination. We're going to loop through it like this, right? We're going to go from right to left, 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 right to left. And we're going to copy it like this. Oh. Why did I say right to left? I meant left to right. Left to right. Left to right. But we're going to copy it in from right to left. Right to left. So if this is XY, we want to copy it to width minus X plus 1 and Y. So if, for example, if this thing is, the width is 10, then this would be 0, this would be 9. 0 and 9. So if we're copying this pixel here, this would be pixel 0, 0. And we want to copy it to 10 minus 0 plus 1, which is 10 minus 1, which is 9, and then 0. So that's correct. So we want a width minus X plus 1. And that will copy this pixel from here over to here. Capiche? That is the algorithm. It's quite simple. But it's always good to... Oh, okay, something's frozen. I seem to be unable to switch between my... Well, this works. I guess that's fine. Except I can't click on this either. And that's kind of a problem. That's kind of a big... Oh, and now I'm getting pissed off. I'm gonna choke a bitch. Is Chile gonna have to choke a bitch? Okay, I can do this. This is fine. But apparently mouse... Okay, now we're good. Now we're good for some reason. Okay. Just gotta remain calm. Serenity now. Serenity now. All right. So, how do we do this? We go msurf at int mirrored x mx is equal to x is equal to width minus x plus 1, right? And then we go msurf, this one? Yeah, I got it. At mx plus y times width is equal to surface at x times width. That's good. That's fine. How's that? That seems rather fine to me. This one uses mx, which is the mirrored x. This one uses normal x. Can't argue with that logic. And now we just return msurf at the end. And that is how we get our mirrored pixels. Nice protected function there. So to create a new surface, clone the mirrored surface, we just go, first of all, let's add a new surface constructor. And we go int width, int height, d3d color pointer to surf. What else we got? That's all we got? It's unsigned. 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 And unsigned. And yeah. Throat. Something bad happened in my throat. Okay, I'm fine. Height. And surface. Surf. Good. How's that? You like it? I like it too. That's something we can agree on. Let's minimize that. So cloned mirrored is just going to be return new surface with the same width as the current object, the same height, and get mirrored pixels. Booyah. We like it. We like it a lot. And we'll create a new keyed surface thingamajigger. Unsigned int width. Unsigned int height. The color key. The yeah, D3D color pointer to surface. We're going to make this constructor. Control X. I hope this is an X. That was an X. Oh, I pushed the wrong button. Now I ruined everything. Zed. No, I don't even know what I'm doing anymore. Okay, good. I think that's where I left off. Okay, I'm going to Control X this one. And I want to put it over here. Good. There we go. I don't want the outside world being able to create a surface in this manner. Just because. I don't think they need to. And if they don't need to, then I'm not going to let them. That is my general... what's the word I'm looking for? Protected... Not motto. But something like motto. Okay, keyed surface, blah, blah, blah. Kind of like modus operandi. Surface. Or like philosophy or something. So we want to do width, height, surface here. And we're going to do key. So there is our constructor with all the stuff supplied. There we go. Now, we still have this, where is it? Virtual surface clone mirrored. So we need this one. We need the keyed surface version. Virtual clone mirrored. And oh, okay, that's fine. We can return a surface pointer, but it's actually going to be a keyed surface. And it'll be fine. Width, height, which we're allowed to access because they're protected, and key, and get mirrored pixels. That should be fine, right? You don't hate me, do you? Oh, you still hate me. Protected function is not accessible through surface pointer or object. But this one? Protected function, new keyed surface. Declared at line 73, which is up here. Right? Wait, why not? Dude, I don't get why you don't like me anymore. Aren't we friends? Protected function, blah, blah, blah. I'm gonna get a bunch of errors because I'm sort of like halfway through here, right? No, it succeeded. Okay, what? Okay, what the fuck? It succeeded, but it's saying that it's bad. I don't even know. I don't even know. Height, D3D color surface. Width, height. Create a new surface. Yeah, it's fine. Keyed surface. And keyed surface creates a new initializes this surface. The parent class initializes the additional key variable there. Return new keyed surface. Surface height surface is not accessible through a surface pointer or object. Okay, this one is really baffling to me. I have no idea. I don't even. What if I deleted this and put it back? Did that work? I think it worked. I'm going to say that worked. So anyways, I have no idea what the fuck that was about, but we have good stuff here. We got technology now. We have a... Ow! Chest pains! God! It's not my heart. Don't worry, it's not my heart. It's just... I don't know what it is. It's on the wrong side of my body to be my heart. Ah. Ow! This hurts. God damn it. I want to pause the video, but my voice will get desynced. Okay, anyways. You see, I created this protected function, get mirrored pixels. And then I call it from both of these different clone mirrors, the virtual clone mirrors, to get, in this case, a surface pointer, and in this case, to get a keyed surface pointer, right? Although it's returned as a surface pointer, but it's actually a keyed surface. But anyways, I mean, I could have just put this all in, I could have taken this get mirrored pixels part and jammed it into the clone mirrored, right? I could have done that. But then I would have had to also copy the same code down here. Are you catching my drift? I'd have to duplicate the same algorithm in two different functions. And if I did that, then let's say later on I found a bug in my my mirroring code right. So I fixed it in one of the functions, but I forget to fix it in another function. And then later on, I use that function, but it's not fixed, and I get some bugs. And I'm like, what the fuck? And I don't remember about fixing it in one and not in the other. I didn't realize I did that. And I think I fixed it. So I think to myself, what could be wrong? Oh, I fixed that. It must be something else. When in reality, I only fixed one version. So that's a problem you get when you're copy and pasting code, duplicating it. You might edit one instance, but forget to edit the other instance, and then you're fucking yourself over really hard. Right up the bunghole. So what you do is you take like if I have to have two different function calls that do almost the same thing, like in this case. Wait, what happened? Oh, I just did that. Okay. Like in this case, I got this clone mirrored, and then I got clone mirrored here, the overrided version, and they do almost the same thing. It's just this one returns a keyed surface, that one returns a normal surface. And the keyed surface has a key, obviously, normal surface does not. But they're almost doing the exact same thing. So you take the part, this is important, people, I'm teaching you stuff. You're getting schooled here. You take the part that is common to both of them, you factor it out, and you make it as a function in the parent. And then both the parent and the child call that function. And the only parts that are different are the parts that are different. And the parts that are same are all factored out into a separate function in the parent. And that's how that problem is made solved. That is how it is made solvent. Throat getting messed up. Body shutting down. Alright, so now we can clone a surface. Let's go back to bidirection here. By surface sequence. I want to finish this surface sequence thing here before we end off. And then next time we'll actually we'll jam it into the sprite and make it all fizzy. I need to drink though. Alright, so technical difficulties aside, I think we're moving pretty smoothly here. So now we need to create a new bi-surface sequence. And we do that, it's going to be similar to when we're creating a normal surface sequence. So let's go to surface sequence. I'm getting burpy. I'm just going to copy this here. Where's my thing? I'm gonna go back. Oh, I love that back button. I'm not used to using it because I've been away for so long, making tutorials in basic mode. Okay, so yeah, all the same parameters. I'm going to do something just a little bit reckless, but not very much. It's a little iffy, but it's, I don't know. I feel like it. I'm just going to take a walk on the wild side. So we're going to initialize our right sequence, which is, I've just chosen that right is going to be the main direction, right? So all the sprites are going to be drawn facing right, and then they're going to be cloned left. And we're just going to go base name n surfaces n hold frames base x base y and key. What, you have a problem with that or what? You probably don't. I just need to add this shit. Right? No. Well, base same is not what we want here. Okay, so now this will be our right sequence will have been initialized. And now we can... You know what? I think we're going to need pointers here. I think by surface sequence is going to need pointers instead of just, you know, embedded surface sequences. I mean, I could do it with embedded. It's not impossible. I'd have to change some shit, but I don't feel like changing shit right now. I feel like leaving shit the way that shit is. So, right sequence is equal to new surface. Oh God, I didn't want to do that. Undo. Cut. Good. Is equal to new surface sequence. There we go. So we'll create a new surface sequence there. And then left sequence is equal to right sequence pointer to clone. What? What is your problem, Bee Snatch? Oh, I know what the problem is. Kind of. Yeah, because I wrote the clone for the surfaces, but I haven't written it for the sequence yet. Yeah, that's a problem. So we go surface sequence pointer to clone mirrored constant. How's that? So far, so good. Oh man, now I gotta do stuff. We need a new constructor, man. We need a new constructor. Surface sequence. Okay, so mostly gonna be all this bullshit. Mostly. But we don't need a name. I'm just gonna put here Chili is thinking. Chili is looking for his delete key. He has found it. Okay. We can create a new surface sequence here. Kinda. Maybe. Pointer to surfaces. Okay. I think this is what we want. Just a dummy constructor that copies everything into the place. Surfaces. And delete that. Put that there. How do you like that? End surfaces, you don't like that. Not one bit. Error. Provides no initializer for... For what? For what, motherfucker? Well, we'll cross that bridge when we get to it. First things first, we want to create mirrored surfaces for every one of our thingamajiggers. So we're cloning mirrored. What we're going to do is keyed surface pointer to C, Control V, M surfaces. So these are our mirrored surfaces. Equal to new keyed surface pointer. It's a double pointer, right? So an array of pointers. No. Nope. Yes. And the size is going to be n surfaces, right? That's how many surfaces we need. Then, for int I is equal to 0, as long as I is less than n surfaces, I plus plus. And mirrored surfaces is equal to surfaces pointer to... Okay, what's your problem? Surfaces at I pointer to clone mirrored. Do you dislike? Of course you dislike, because I did it the bad way. I made the bad game. There we go. How's that? What? Value of surface pointer cannot be assigned to... That's true. That is very true. I could make this just a normal surface pointer. Would that break anything? I feel like it wouldn't break anything. Now I'm starting to regret making the cloning for the base class and the child class, making it for surface and for keyed surface. But I'm going to make this surface sequence a little more flexible so it can work for keyed and unkeyed surfaces. As it stands, it only works for keyed surfaces. So we're going to make this. We're going to make it all surface array of pointers to surfaces. Now that's broken up here. Surfaces is equal to new surface pointer. And then we make a new keyed surface, and we make surfaces point to that. And surface pointers can point to keyed surfaces. But keyed surface pointers cannot point to normal surfaces. I have explained this. It is known. Now this one has to be a new surface array of surface pointers. Now we're happy. Now we're happy everywhere. Everyone is happy. Unless I forgot something, in which case it's going to fuck up horribly and explode. The Hypers gameplay on YouTube. Alright. What else? I think that's it, right? We just clone every one of those things. And then we have our cloned surface, and we return a new surface sequence. This is going to be a pain in the ass. Okay, so surfaces, we go M surfaces, N surfaces, N hold frames, base X, base Y, key. How's that, mother? Doesn't look good. No, sir, we don't like it. Okay, so it doesn't like key. It doesn't matter because key is stored within the surface sequences. So, we don't need it. We don't need key. When we clone the keyed surface, this is going to be a surface pointer. That works. Now, what is your problem? What is your malfunction? Aha. Could it be this? It probably is. Okay, so now we are able. Well, let's build this anyways. So ostensibly, we're now able to clone a surface sequence, and that will give us clone. What now? Seriously, dude. Now you're just pissing me off. I made your function. What more do you want from me? Visual C++. Where is my thingamajig? Surface sequence. Okay, so we have a function. It's called clone mirrored. It's public. It exists. Yes, it exists. It's a thing. I made it. Why is it not working? Let's go to our class viewer. Surface sequence, cloned mirrored. Definitely a thing. Definitely not a figment of my imagination. Right sequence is a surface sequence. So, in theory, we should be able to clone, but we can't. We can't. Why not? Why isn't it here? I think it's just my IntelliSense is probably fucking up. I mean, to be completely honest, by surface sequence isn't what you would call kind of connected to the rest of the project. I mean, it's not included in anything, but that shouldn't matter for IntelliSense. IntelliSense should still be doing my shit for me. Right sequence pointer to. Oh, I hate it when my IntelliSense doesn't work. Mirrored. Because I can't spell shit, and so it's just gonna fuck me over. Clone mirrored. What's your problem with that? Has no member clone. The fuck it doesn't. Service sequence totally has it. It's right here. Look at this. Clone mirrored. It's right there. It's right there. Look at it. Urgh! God damn it. And building is gonna help because this isn't included in any translation unit, any CPP file. So even if I build this mother, it's not going to help. It's not going to help. Nobody's going to help you now. Nothing's going to stop us now. So I'm just going to keep going. I'm just going to power through. I'm going to power through. Include bidirection. We got to have a bidirection here. dir, and that's going to store the direction that we are facing in. And yeah, base y, bidirection dir. I can't make it equal to something because I can't. That's fucking. So when we create the surface sequence, should we be able to determine which direction it's facing? I'll leave that option for later. So it's going to default to facing in a certain direction. And that direction is going to be bi-direction pointer to, or I could do it like this, right. So it's going to default to facing right. Why don't you like that? Why don't you like it? Expression must have a pointer to function type. Ah, I did the dumb thing, didn't I? Do you know what I did? I will tell you what I did. I created a enumeration with left and right, and then I created static functions that are right and left. So we got a little kind of naming collision here. How to solve my naming collision problem? Make right, make left. That is my concession. Let's go back. Back. How's that? Oh wait, now it's not a thing. Make right, make left. There we go, that's fine. Doesn't mind that. So we make a new right object, and that initializes the dir. Bidirection, make right. It's kind of long, but whatevs. Whatevs. Okay. Now, so we're just gonna, all bidirectional surface sequences default facing right. That is the behavior for now. Later on I might put in the option to specify direction in the constructor, but for now we're not going to do that. Okay, so we have a constructor. Now we need to do draw. Void draw const, oh wait, D3D graphics GFX. Is that the way we do it? And we do, this is how we do. If dir dot is right, right sequence, pointer to, let's get rid of that. I need my IntelliSense. Well, for some reason, this is finally decided that it's okay now. Oh, IntelliSense, you are the bane of my existence. Draw. X, Y. Oh, right. I need X and Y. Okay, that's fine. That's fine. I got you. X int Y. Draw. X, Y, GFX. Copy this. Paste it here. Put an else in here. Else if is left. Then left sequence draw. And that's how we draw. Now we also need advance. Where's my thing? What's it called? Surface sequence? Surface sequence. Here it is. And draw advance. Actually, go back. Oh, I can't go back. What is this? What is this witchcraft? There we go. Okay. think my computer is breaking down as we speak. Advance. So we could actually do this in two different ways. We could make it so that we don't store direction in here and we just pass direction in every call. Or we could store direction and then we have to make a function to set the direction. So advance, I'm just going to do this. Copy that. Delete that. And we go, if it's right, then right sequence advance. Booyah. And if it's left, then left sequence advance. So draw, advance. What else you got for me? Bring it on. What do we get? Surface sequence. Surface sequence. So we got advance, draw. And that's it, really. So, but we need one more here, and that is, or two more. I'll start with one more. Set direction. By direction D. And we just go dir is equal to D. And there we go. There is our by surface sequence. So when we include like this, we have to recreate all the functions for this. Whereas if we had inherited from surface sequence, a lot of these functions would still work. We might, it's a toss-up. Never mind. I'm just talking, but it's mostly not making any sense anymore. My brain is shutting down. But this is the bi-surface sequence that we're going to need. So now we can go. The final test is incorporating this into the sprite, not actually taking advantage of the new functionality, just trying to see if the old sprite will work with the new surface sequence here. So we're going to go to sprite. What are we going to go? Sprite core, I think it is. So we're going to make this a bi surface sequence. Bi. We're going to make this one a bi. Doesn't like it. It's like, I don't like it. Well, probably because doesn't know about it. Just doesn't know about it yet. Now it knows about it. Now, is that alone going to be enough? That might actually be enough, but we might have errors. No, failed. I made the interface pretty similar, so I don't see where the problem is. Error. All right. I got to change these ones because I actually do make surface sequences here instead of bi-surface sequences. So I've got to specify. Let's rebuild that. Yeah, but everything else is fine because, I mean, bi-surface sequence, all the functions and everything are the same, so the other codes shouldn't have to change. It's gonna be good. It's gonna work. It's gonna work the first time. It's not gonna crash. It's gonna be fine. It's not gonna crash. See, it's not crashing. Not crashing. Yes. So the bidirectional surface sequences work in that, you know, they don't crash when we stick them into the place where the normal surface sequence was. So it's homework time. It's homework time. It's time to give you the homework. You guys love homework. You know you love it. So what's the homework today? First of all, I forgot to put a thing in the bi-surface sequence. I forgot a little a function kind of thing deal. Can you guys figure out what it is? I'm sure you can. If you look at it hard enough, you'll know. I forgot something that's pretty important. It's kind of a big deal. So see if you can figure it out and fix it in there. And the second thing is, if you're up for a little bit of a challenge, why don't you take a crack, if I can get this thing compiled, why don't you take a crack at implementing moving to the left, right? Now that we've got the by surface sequence all set up and ready to roll, try implementing moving left. So you've got to play around with the player running. That's what we're going to be doing in the next video. So, but try it for yourself. Just make sure before you do this stuff that you back up the your solution folder once you've got it working, just like I have in the video. Back that shit up, and yeah, then you can make your own effort. And if you fuck things up horribly, or even not, you'll have the backup, so you can revert whenever you want. Because when I do the implementation of moving left, I'm probably going to do it a little differently than you will. And in order to keep up with the tutorials, you're going to have to kind of keep it the same that I'm doing it. But I think it'd be a good challenge to try to get that working yourself before I show you how to do it. So if you got some time, try that out. And also, like I said, there's something missing from something pretty glaring that's missing from bi-surface sequence. So see if you can spot that and add it in. And that's the homework. And next tutorial, we are going to, like I said, we're going to work on moving left, and that won't take that long. It'll probably be done pretty quickly. So maybe I'll also add in to that video the beginnings of collision. So we'll start with colliding just in the case of running. We're not going to get into jumping just yet. We're going to stay on the ground, stay frosty. And yeah, that's it. So get on the homework, and I will see you next week. Later.